All right, so here we have a 2002 Hyundai Santa Fe. This has the 2.7 V6, and this customer has brought the vehicle to us for having a code for a mass airflow sensor being low input or out of range. So we're going to go ahead and take a look at this several different ways. First, we need to verify where the code came from. So this could be a bad mass airflow sensor. We could have bad voltage. We could have like a bad connection or a bad wire, something like that. Then the worst case scenario would be that the PCM is just not processing the information correctly. So we're going to go ahead and verify this code. We'll start it up. We're going to read some of the data that we see present with the sensor. All right, so here we are. We're looking at our mass airflow. So what we're looking at right now is the two things that we're really concerned about is this voltage. That would be, the car sending voltage to it and then it interpreting back this other data where it says, 35 pounds an hour of airflow. So this sensor kind of works in a way of it heats an element up 100 degrees over the temperature, and then the air flowing over it cools it back down. That cooling effect tells the computer how much air is flowing through. So as we increase RPM, we increase airflow, we should see everything progressively move up. This right here we know right off the bat. We should be at idle, that should be a half a volt. We're barely registering any voltage at all. We should be a half a volt. It should jump up to 2 volts at like 2000 RPM. So we're going to raise the RPM. Yeah, we're not really seeing any movement. We see it interpreting data, but not enough to it's set a low input. So we want to go now, and we're going to go underneath the hood. We're going to check for voltage at the sensor, make sure our connections are good, make sure we don't have any bad wiring, any bad connections. So we'll go ahead and do the voltage test of the sensor now. All right, so here we are under the hood. This is our mass airflow sensor. This is no good. So basically the mass airflow sensor is calculating the amount of air going into the engine so it knows what to make the timing and the fuel. It does take the throttle position sensor. It's the calculation to know how much fuel to put to air. So this right here is taped for some reason. I'm sure it's taped because it's ripped. When we're driving, the engine is flexing back and forth, forward one way, reverse the other way, but then just driving, throttle, decel. It's stretching these accordion pieces out. Any air is going to be pulled through here rather than trying to go through a restrictive air filter. It's going to pull through here. Air is going to enter after the meter, and it's just going to have a poor running condition. It's never going to be right. That is one thing that could set the code. Although we did see a voltage problem, this is probably a drivability problem he really didn't realize, or someone tried to do something. This stuff is all bad too. We see a bunch of broken. We still have, we did a little bit of inspection here trying to see without moving too much. What we're going to do is we're going to do it's a wiggle test. We're going to start it up. We're going to wiggle the connector. We're going to yank on a little bit of wires. We're going to try to see if we can push things around and change the driving condition. If we can dramatically change the driving condition, that would just point our search at where we're playing with what we're wiggling. This would be like the simple wiggle test, going into the repair. All right, so we're stabilized with an idle. I'm just going to go. Make sure all our connections are good. Look at that. We can pull that sensor, the cover on it pretty good. So if there was any wire pinched or shorting out, we would definitely agitate it right now. All right, so I'm gonna go inside the car. I'm gonna basically put my foot on the brake, put it in gear. I'm gonna go drive forward in one time, pat the gas. We're gonna see the engine move around. I'm gonna do it the other way, pat the gas. What we're gonna do is we're checking the motor mounts out right now to make sure that the motor mounts aren't ripped, and that's why we're getting too much twist and too much pull right there. So. We got some movement. That's normal. It is a little bit on the looser side, but we didn't get any big jumps. The big jump would mean that the bushing is just ripped. This is all acceptable. So what we're going to do now, let's peel this cover off first so we can get a little bit more room. Why are we going to peel this off? We really don't need to. We're going to get to this clamp back here. But we want to see what the EGR and the PCV system looks like, because if we have a hole in one of those hoses, that'd be like a big vacuum leak too. It would be unchecked air. So we need to inspect that. All right, so this little hose here is what we wanted to look at. It does have a little bit of oil on it. So if this hose was cracked, this would be another, where it's letting air into the system that is unchecked. So that looks pretty good. All right, so we're going to do some voltage tests now. We have the key off. All right, so here we are at the mass airflow. We just want to inspect to make sure. Make sure our pins are good in there. Everything looks pretty good. All right, so what we're going to do, here's our fuse box. All right, so we have one fuse in here, this 10 amp fuse. So this 10 amp fuse, it runs out, and then it bridges out, and what it is the 12 volt signal going to each sensor. So this sensor gets it, the throttle position sensor gets it. All the sensors that are checking stuff, they all get this. Well, it's split into like 3 ECM fuses on this car, but so this one ECM fuse feeds this in the throttle body. So what we're going to do is we need to make sure that our 12 volts getting to our sensor is our 12 volts, that there's not any kind of corrosion in the connection or anything like that would act like a resistor and would drop out our voltage. So we'll go ahead and we're going to turn the key on, and that'll set us to our loading out our 12 volts to the system. All right, so we're key on, engine off. And so we have our true battery power. And then this is our fuse that goes out to the mass airflow. We just check both sides. Oh, look at that. All right, so then this also comes in. So we have the same voltage that we have All right, so we're not dropping any voltage between, going battery to fuse to the sensor. All of our connections are looking good. In this repair so far, we have found our 12 volt source is getting to it. We have 3 wires. This is where this far wire onto the right side here, that's where our 12.5 volts is coming in. On the far side here, this is our supplied ground by the PCM. So the PCM is giving this ground. That could be something that could be concerned with skewed data. How you would check that is you would have this plug unplugged, you'd have the PCM unplugged, the computer, and you would be doing an ohms test from this wire to the PCM to make sure that that wire has the most minimum ohms or resistance across it, so it is a direct, there's no corrosions or anything on that circuit. We're kind of not going to check that because we do believe that we have a mass airflow that is bad, and we also have some other issues here that we're thinking that it's going to be this. But to keep on going on a wiring, or that code could be the PCM, could be the wiring, open or short. So checking that wire for its integrity would be one. The same with the middle. The middle is the returning signal. So what we were seeing, that voltage that was stuck at 0.02, that would be where this wire, that would be the sensor going out back to the computer, telling it that's where that signal comes from. So once we're going to take this off, we're going to replace the sensor, we're going to put a new hose on it, we're going to get the car started again, and we're going to go back to the scan tool, and we're going to look at our data again. We kind of did jump to the part problem versus verifying it 100% that the wiring is good. I don't believe it is. This is kind of where the tech jumps in with an educated guess on the next move. So we'll go ahead and remove this and replace our bad hose, our new sensor, and then view the data. Oh yeah, I mean, we weren't even, the tape didn't even go out that far. Oh yeah. So we weren't even taping that. We were in that groove there. There was a huge hole right there, right on the bottom. So every time the motor flexed, that thing was opening up. Air was supposed to be going through here to be checked. It wasn't. It was coming through here. That just skews the data all up. It has no idea what it's seeing. So this is kind of like an air baffle. This would be kind of storing extra air inside of as kind of a surge, or stepping on the gas, manifold to port vacuum kind of issues there. Here we got our new air intake from Auto Parts Direct to You. All right, just making sure that everything is the same. Looks like there could be another port there. That's what I was just checking, making sure that's not blown through on the other side. So we have our one for the bottom. Yeah, I mean, this is original stuff. They must have had some kind of problem. They have redesigned it from the factory, or this was on a newer vehicle and it replaced an older part. But it looks like they put a lot more engineering in this lower half here. All right, so we'll go ahead and put that back on. We'll go ahead and put our hose back on the bottom. So we're going to go ahead and get everything hooked up before we tighten any of the clamps down. So here we have our new mass airflow meter. So they do have arrows on them to show the flow. Of course, we're checked by the connector on this side, so go ahead and loosen that up a little bit. clip our box back in. Go ahead and tighten our hose clamps down, making sure that all of our clamps are in the right, you know, we're slipped all the way on the component. You know what I mean? Our lips are all the way to the edges. All right, so here we are looking at our data again, and you can see, so we do have some movement now. We're where we should be. I mean, 1/2 volt should be our idle set. So we're very close to the 1/2 volt for our idle set. You can see how much, okay, so now we're saying we have 26 pounds an hour. We were like 40 something pounds per hour. So what's the computer gonna do? The computer is gonna add more fuel because it thinks it needs, because it's got more air, so it needs to put more fuel. So we were way off, you know, on our fuel mileage. Whether or not they noticed that or not, that's debatable. But this is what we're after right here. So we're at, you can see it starting to settle down a little bit. We're at 5.9, 6.1. So we're gonna go up. We're at like 700 RPMs right now. We're gonna go up to 2,000, and we should progressively watch it go up in a smooth, as long as I smooth up the throttle, we should watch it. So we're almost, there's 2,000, 2,500. We should hit 2 by 3,000. And then we settle back down on an idle. So we did have a bad mass airflow sensor. That is kind of why we didn't check that other wire. So we would have came back here and that would have been on 0.02 with a new sensor in it. For sure we would have known we were at a wiring issue or a PCM. The PCM's not hearing it. So we're just chopping down those steps there, but we did get it. This is what we were after. So we'll go ahead and do a test drive on this vehicle, make sure everything is good, and that'll be that.